Hello and welcome back to the Database School podcast. My name is Aaron Francis. Today I'm here with somebody I've known. What goodness, it's got to be 12 years at this point. I've
Yeah,
known
easily
you.
over a decade.
It's
So
been a long, long time. So the other voice that you hear is my dear friend Mike Buckbee. Mike and another one of my friends are the co-founders of Wafris, which I'll let you explain here in a second. But
sure.
yeah, like I said, I've known Mike for more than a decade, and he recently just wrote this amazing Redis to SQLite piece that we're going to talk about today. So, Mike, do you want to introduce yourself further?
Sure. I'm a longtime developer in a lot of different frameworks and a lot of different contexts. Aaron and I worked together at a former job. There was a public cybersecurity company, and I've done some form of cybersecurity work for even longer than I've known Aaron. So,
Which is saying something at this
which
point.
is saying something. And the latest iteration of that, and sort of all of the issues I've had with all the systems I've used and built, to date, I'm trying to address with Wafris. So Wafris is open source client web application firewall. And it addresses one of the big issues I have, which is there's this sort of brutal asymmetry where there's lots of script kiddies and attackers out there, and it's trivial for them to write a one-line curl, command, loop over it, and hit 1,000 sites and sort of mess with 1,000 sites. It's very hard for those 1,000 sites to deal with that. And so that's a good, sort of, starting point for my philosophy for those things.
So before we go any further, can we get a spelling of Wafris for the people that are going to go look it up? Can you give us a spelling and a little background, maybe?
Sure. It's Wafris, Wafris, and WAF stands for Web Application Firewall, which is something that is typically used by a lot of big enterprises. That's a lot of my customers for my other Web Application Firewall product. And it's something we're trying to bring down to more people. The original thought was, ironically, somewhat Web Application Firewall and Redis, and we're going to talk about that. But also, sort of my thought on naming startups and stuff is you need a unique, weird name. Partially because it's a lot easier to get the domain for it, and you don't have to do my thing app or tries mythingnow.com. Also, it gets around a lot of weird trademark stuff internationally. It's just so much easier in a lot of ways. Yeah, no one's competing for us on SEO for Wafris. So yeah.
No, I should think not. Yeah, when you said you were switching to SQLite, I joked with you on Twitter that you're going to rename it WAFQuilite, which is it's not better. It's much worse.
It just rolls off the tongue. Yeah.
Okay, so I want to talk a little bit before we get to Wafris. Tell me a little bit about I know all of this background. Honestly, you got me my job. That's the thing that Mike didn't say. He's too kind to say. I got that job that I worked with Mike at because he got it for me, which was very nice of him. And so back then, what were you doing? And then you mentioned another WAF product. So give us a brief cybersecurity run through of Mike's history.
Sure. So I don't even know if you know this, but back before I even had moved to Virginia or met you or anything, I actually did essentially cybersecurity consulting, in a previous role. And I had a CISSP, which is this certification you need to get, and you have to take a test and get people to attest that he's actually worked in this for a long time and stuff. And I had those sort of roles, and I was always sort of doing software development on the side. I didn't start off doing software development. I mean, similar to you started as a CPA and then got into software development. And then from there, just more and more software development, and really got into, some marketing things. So at Varonis was our old company. I was the director of demand generation, which is doing a lot of the marketing pieces for content writing and for ads and stuff. And that evolved over time as they grew. I had joined them pre-IPO. And then as a side project, I had started Expedited SSL in the Heroku Salesforce ecosystem, which did certificate installation. And then later on, I had started Expedited WAF, which is an enterprise web application firewall that's in that ecosystem. And again, just a lot of issues with it, and a lot of frustration that, due to sort of how it's designed, it can't be a default. It can't be something that just every app just has. And again, the frustrations are, it's really easy to look in your logs of any application and find like all these IP addresses that are like, oh, I really wish they weren't doing that. Maybe it's not actively harming me, but it's not great to have this bot looking for .env files in every directory in my machine. It's not great for this bot to be testing like, oh, is this running Java with this exploit? And just like thousands and thousands of those. But there's no real good way to just go in and like click a button or say like, I would rather not have this IP address ever make these requests again. And so that's part of what we're trying to deliver on with Wafris.
So before pre-Wafris, you were strictly in the Heroku ecosystem.
Yes.
And you were finding, was it the platform integration points that you were finding difficult, like just the stuff they gave to you, or why did you decide to break out of the Heroku ecosystem? Hey, I hope you're enjoying this. Just as a reminder, you can learn more about SQLite at highperformancesqlite.com. I'll get out of your way. Back to the interview.
I think the Heroku ecosystem and what we had was really good, and still I have, I think, nearly 1,000 customers over there, and I think what it more is that the cost structure of it, because it works as a traditional web application firewall through DNSs and proxy systems, and it's not something built into the application. There's, there's side effects to that architectural decision, just like everything. Mm-hmm. One of those is that it's very hard to bring the cost down on that because of it. And the other one is it's very separate from your application, and there's a lot of sort of issues there. And the mix of that results then in behaviors that only enterprises or people that are almost forced to buy it. So it's a lot of startups that are like, oh, we're going to integrate with an insurance company. We're going to integrate with a bank. And the banker or the insurance is like, great, fill out this PDF checklist. And like one of them is like, do you have a web application firewall? And so there's a lot of resistance from developers. Like, does this actually do anything for me? Does this do stuff? I don't know, you've heard this. I have like unending amounts of stories of like, yeah, I got on a call with this person and their site was messed up and they had all these issues because they were under attack. And so we turned it on and made some settings and it stopped the attack. And so the web application firewall, I feel like, picks up on the operational security issues that are outside of the framework. So Laravel, Rails, Express, all of these are made by brilliant people that have an eye towards security and take great pains to make sure you're developing that application well. But depending upon how you deploy it, the web server, the actual HTTP server that's in front of it, it may have issues that you can't deal with out of the framework. It's still difficult to deal with, like rate limiting issues. I know Rails and Laravel and Express all have built-in rate limiting now, but even with that, you still have issues of like, well, an actual attacker who is doing a credential stuffing attack, which is just pumping thousands of usernames and passwords into your system, they're rotating IP addresses. So it's trivial for them to get 1,000 IP addresses. So even though you have a rate limit of like, oh, well, 5 attempts per hour, that's still 5,000 attempts per hour. That's not great. That's a hard thing to tell your boss. Like, yeah, I fixed it. Only 5,000, crazy bot attempts an hour on our login. So you need this other set of tools to help you stop those sort of attacks, to prevent them. And that's what we're trying to provide with Wafris.
So the architecture, why don't we do the architecture of Wafris before you switched to SQLite, and some of because you'll have some pretty unique constraints based on where you sit in the stack. Because I think where you sit in the stack is you sit between literally every single request and the application in which Wafris is installed. So it's a pretty hot path. It's a pretty brutal place to be, honestly. It sounds a little bit stressful. So talk to me about the architecture and how Wafris even works such that you're allowed to be and want to be in the middle of every single request.
Sure. So part of what we have, I guess there's two sides to it. There's a server configuration management side, and there's a client piece of this. And so we refer to the server management side as hub.
Okay.
So on Wafris Hub,
And when you say server, you mean your server?
yes, maybe a better
Okay.
term is service. There's a
Got it.
service.
Okay.
We
Hosted.
run this management service, and partially, again, I'm talking about like all the issues I found. So a very typical thing is I will talk to people, and what they will have is they will have a web application firewall. They will have their application, their Rails or Laravel app, and then they'll have a separate logging service. And to deal with anything, they have to jump between those, and they just literally are copying and pasting. They're going into their logs, extracting out a bunch of logs. Maybe they're pumping them into like an Elasticsearch cluster, and they're doing grouping on IPs, and that is just a rough way to live. And it's really hard to be dynamic. And so we're trying to take all of that and make that loop really tight, that feedback loop, and have it live on Hub. So one of the first things you see when you log into Hub and you have the system up and going is just a list of, here's the top 10 IP addresses making requests to your site over the last 24 hours and how many requests. Now, that is not a complicated thing to conceive of. Oh yeah, but just how many requests. That is a difficult thing for most developers to pull out of their systems, which is just, and it shouldn't be. And it feels like if we were starting today, like designing all these systems, we would have a system where it's easy to get that out. And so that's really what Hub is. And then I think it's a very, clear path to see like, oh gosh, we don't do any business with, Indonesia or Canada or Finland, but this IP address is our number one requester. And that is not uncommon. Like I talked to a company that was doing essentially like internal HR software that if you had an attack, like if something happened, you could report it in the company. It was anonymous to this outside thing. And they found out, only doing business in the US, the majority of the requests to their website were actually from China.
Not great.
Not great. And nothing against China or these other countries, but it just doesn't make sense. It just doesn't make sense. So that's what Hub is. And so then you can block that IP address, and that gets communicated down to the clients. And so the client is a middleware that lives in Laravel or it lives in Rails, or somewhat complicating things is it could also live in Caddy. It could also live in Traffic, which is an ingress controller. It could also live in Nginx because we do.
That's cool.
So we can live at these.
So it could live as a middleware in Laravel in code. So it hits the Laravel application and then starts through the middleware stack and it hits the Wafris middleware. Yep. Or you could build it in as, what do they call them in Caddy? Is it modules? In Nginx, it's modules, right? Okay. So you could build it into one of those two and it never hits your application at all?
Yep. So we have.
Okay.
So, and we have this functional. We have a functional, and we'll get to V1 and V2, but we have this functioning right now with Redis, which is what we describe as our V1.
As your data store on the client.
Yeah. And so the issue is that we have, say, I know you're most familiar with Laravel. So you have Laravel, and then you have your Laravel set up, and then next to it, you have your Redis instance. That you've set up. We need access from Hub to that Redis instance basically to write these rules. And so then
you need access from the outside world. You need access from back home. Got it. I think I see where the problem lies. Keep going.
Yeah. And so that's doable in a lot of ways. And that's like you can go into AWS, and we have a lot of people on AWS, and set the rules for that, or you can set up a different server, or you can do things, but it's not easy. It's not just install it. And
so if I'm understanding right, it sounds like they share the client reads out of a local data store. The Hub writes to what is your local data store, but to it is a remote data store. And that way, when a request comes in, you're just asking your service right next door rather than trying to phone home to some API over the open internet, which sounds like a nightmare.
Exactly. And the constraint there was it's the hot path that every request to your web application needs to be evaluated on the rules. And I always think of should this IP address be blocked? That's the easiest rule to think of. So we have to check something that says whether this IP address should be blocked. And something and this is again the people I talk to, it's easy enough to think like I can go in and I'm going to write my own constraint in the framework that's going to block this, or I'm
Sure.
going to set this as like an environment variable or something I can update. And then I see those systems get out of hand where literally talk to a customer and they had 750,000 IP addresses in their own homegrown system.
Just
that
in
they
a
were
big
trying-
list.
Not great. Not great.
Not great.
So, and no way to manage those. Like in Rails, it's rack attack is something that's used a lot, and you can go in and you can put exactly that, and it works. But there's functional limits to it. You don't have the feedback loop. You have to. So anyway, so that's V1 is these middleware clients and HTTP servers and ingress controllers and frameworks that we're connecting to the application, a local Redis, and to Hub, a remote Redis instance. And for the reasons you said, it doesn't work. Like it's hard to get going. We found, I think the phrase I use in the article is we shouldn't make people that are just trying to get this installed, we shouldn't casually make them Redis database admins. Like that's not something people want to bring on to themselves. So all of that coalesced around, we need a better way to do this. And what we turned to was SQLite. And with that same sort of set of constraints, we then had to do this big re-architecture to move pieces around and to think about things differently and to make them work with SQLite. And I think a fairly unique way because we have sort of unique constraints on this.
So I want to talk about this from maybe two different approaches, which is like the operational flexibility or benefits that you got out of SQLite, and then maybe like the structural, the data structure and performance benefits. But first, before we do that, how was this all stored? Because I imagine what you're storing is IP addresses or ranges or something like that. How was this all stored in Redis? Because I know they have some specialized data structures for this kind of thing.
Yeah. So you said it was okay to get real nerdy with this stuff. So
Please.
we're about to take that dive.
Yep.
So there's two kinds of IP addresses. There's IPv4 and IPv6. And something we do a lot of in the application is look at CIDR ranges. So CIDR ranges are just like a start and a stop IP address. And we need to represent those in such a way that we treat them almost as a key, that if you're between this range, that means that this IP address is in this country. Or if you're in this range, it means that you are part of this reputationally bad IP group and we need to get rid of you. Or it's a custom block that you have decided that like, oh, we don't want to have any traffic coming from this provider or this country. Or the opposite, which is that, oh, we do want to allow all of our internal traffic or all the traffic from our headquarters. And so for a single HTTP request, we have to hit 4 different sets of these ranges to check them all in worst case scenario, because you have to go, that's just what you have to do. So this is like our most arduous set of queries is checking these ranges.
It's checking these ranges because it's not necessarily a strict equality. It's checking to see if an IP address is contained within any set of range. Got it. Okay.
So before we started this, I was going to ask you, so given that I feel you're far ahead of me with the database structure stuff, how would you have structured this?
See, but here's where I'm far, far behind you on, and it's the network stuff. And so when we're talking about CIDR ranges, vaguely in my head, I see a /24, but like, I don't know if that's super right. Like, is that a CIDR range when you do it that way? Okay. So I know that in MySQL and Postgres, they have specific data types for IPs, and I think Postgres has it for ranges. I don't know. I forget if MySQL has it for ranges or not. But how would I do that? Goodness, probably I would... Oh, man. I know they can be converted to integers as well, so I might store the start and end as an integer. I don't know. I have no idea. I know with Postgres, you could do some sort of like just overlapping thing and see if a point is contained within a range, but I have no idea how performant that is. So I don't know.
So everything you said is something I've tried. So I've tried storing these as integers, and there's a
Uh-huh.
lot of like weird, I'm just going to refer to it as bit fiddly stuff you can do with it.
Yep. Mm-hmm.
So, and for Redis at least, there is not, to my knowledge, a range sort of operator.
Mm-hmm.
So there's not a special data type for that. Another complication here is you're absolutely correct. You can take an IP address and a range and get the first and last IP address out of that range, and then you can convert those to integers. Seems very
Good so
straightforward.
far. Mm-hmm.
That only works for IPv4. If you want to support IPv6, IPv6 is so huge that the integers are larger than a big int. They're larger than can be represented as an integer in your system.
Nothing should be larger than a big int. Okay, yeah, that makes sense. I didn't think about that.
Yeah. And so, again, in trying to optimize this, we also ideally, we didn't want to have two structures. We didn't want to have like an IPv4 lookup and then an IPv6 lookup.
Yeah.
And this is a fun fact. Most of the systems that actually do the translation of an IPv6 into an integer, they cheat. They don't do the actual math on it. They do some like weird set of heuristics and regexes and math in order to have a more performance. So if you use like an IP adder,
Really?
yeah, because again, it's just ridiculous how big these numbers are. So
Interesting.
in Redis, what we settled on was using a sorted set. Now, a sorted set is usually used for a leaderboard. So you have essentially a key and then you have a score. And so this works out great that you can have like, oh, Mike's high score is, 1,000, Aaron's is 1,001. And then like you do something in the game and it increments them and all of those operations are really fast. And it's really fast to get out like a chunk of it to say like, oh, Mike is at this spot and we'll get the 10 above and the 10 below.
Okay.
And you can imagine like, paging through a high score list for that. What we discovered was if you set all the scores to 0 to the same value, it forces Redis to use lexical indexing for this, which basically it treats it like it's an alphabet. So it goes, and to do the search through it, it looks for the first column and the second and the third and fourth.
It sorts on the keys instead of the values if they're all set to 0?
Yep.
Okay.
So
This is absurd and I love it already. Keep going.
yeah.
So what did y'all, okay, keep going.
So this is just the basis of this. And so then what we did was we took the first and the last IP address out of the range, because we can calculate that, turn them into an integer, 0 pad it, so all of the columns are the same length.
Oh, because you're sorting alphabetically, not numerically.
Yes, alphabetically, lexically.
Fake alphabetically, yeah.
Fake alphabetically. And so, and then that's not enough, because now you just have this series of numbers, but you don't know if you just look at any two of them in there, like, is this the first and the last in this? And also, because it's almost like ideally, like in my heart of hearts, what I'd love is almost like a hash. Or a dictionary where the key is a range and then the value is a single value. But of course we don't have that. So then what we do is we append onto this essentially a code that says like what rule ID it's for or what country it's for or whatever else.
Oh, jeez.
And so we have 2 entries for each of these. So what you do is you look up, and remember I said earlier you can do a sorted set and you can then look up like the 10 above and the 10 below.
Sure.
So we look and we do a lookup and we find the one above and the one below the value that we're looking for. And so then we take those and we strip off the end code on
Your
them.
little secret code at the end.
And if it's the same on both, we know it's within that range.
Okay.
And this worked. And so this satisfies the requirements
insane.
of a single data object that's in Redis that works for IPv4, it works for IPv6 ranges, and we can do one lookup on this. We can store keys, and that it's very performant. And we're going to talk about the article and the switch to SQLite and the speed difference. This really wasn't about that speed difference. I mean, like, that's great. We're getting a better speed difference out of, SQLite, but this was never really the bottleneck for this, like this architecture. So
this lexicographical sort thing, it worked. It totally worked.
It totally worked. It took forever to figure out. We refer to it as
how many things do you think you went through between the INET masks and the integers and other, like, how many iterations did it take to land on this insane setup?
So many. Also, there's a whole other thing where we taught ourselves Lua, because this is all done not in any language anyone else uses except for Roblox developers.
Of course, Redis and Roblox, that makes sense.
Yeah. So this is essentially in a stored procedure that happens inside of Redis. And so we would take the request, package it up a certain way, send it to Redis, and along with the script, and the script would actually do all of this stuff to, like, peel it apart and stuff. Not, and it all worked. Like, this was not the problem. The problem was people couldn't install Redis properly after this, because it's not what they do.
Sure.
So, yeah. So
you've got it working in Redis. The data structure is wild but genius. But you're hitting operational roadblocks because people are like, you want me to do what? To do what? I just want to block an IP address. And so that, from a, I guess, technical, but more from a business perspective, that was like, this is not workable. We can't keep asking people to install Redis and them say no and not ever, sign up. So what happens next?
So what happens next is, Ryan, my co-founder, and I make the decision that we need something different. And a lot of this was also driven by, I think, changes that we did not initially identify in the market, which is that everything is becoming more distributed. Everything is becoming multi-region. Everything is, that's just the standard for how apps are deployed in a way that I didn't really internalize, And so that was the other piece of this. Everything I said is true about the difficulties installing Redis, but we also had the difficulties then of, like, oh, well, if you're trying to operate in both, a data center in Ireland and one in US East, well, now you have a transatlantic lag, and you don't have one singular source of Redis, and you could do, like, crazy stuff like make followers and things. Again, no one wants to be a Redis database admin.
See. So now you're managing a Redis cluster.
Yes, or this other architecture. Again, too much for people to deal with. So decide on SQLite. And in order to do this, of course, we have to go through the same machinations. And so even just to test this, like, will SQLite work? And the way we conceptualize this is there's two halves of what we do. There's essentially like a read half, which is reading out the rules from the data store, whatever it is.
That's local to local, right?
Yeah, but and even just in the abstract, like from a top-level design document, we have to read the rules out, and then we have to report on them, like what we did. Like, did we block this request? Did we allow it? And that's sort of the right, quote unquote. If you're listening to this, I'm making little bunny finger quotes. But yeah, so that's where we were. And so I made this testing harness, because then I had to re-implement, like, well, I know what the best way to do these ranges is in Redis. Now we have to reinvent that for SQLite. And luckily, it turned out the most performant way to do that was the same thing. So we've actually implemented basically the same thing in SQLite. And, we have a bunch of developer friends. I nerd sniped, I think, half a dozen of them.
I think you did, yeah.
Into, like, this is the best way I can figure it. Can you do something better? And had, like, a little bit of test code. And everyone else tried it, and they couldn't come up with something faster. So
I think I tried it, too. I think I tried it the first time around as well. And I was like, I have no idea what's going on here. I don't understand. Yeah, I remember. And if you're not familiar with nerd sniping, it's exactly what Mike just described, where it's like, you give a nerd something and you're like, hey, I don't know, this is the best I could do. And they're like, well, let me take a look. And then they wander back 6 hours later having taken a look. That's exactly what happened to everyone when you presented this problem.
Yeah, and if I am nerd sniping people here on this, and you have a better way to do this, this is open source. Like, you can actually go to, like, our repos for the clients and implement this.
That is going to be so interesting if somebody's like, no, I've done this before and it's this other weird thing.
I would love that. So, but yeah, no, or reach out to me on Twitter or whatever. I would love to talk to whoever can do this better. Because it's such a cool part.
SQLite famously very, very few types. And so you're shoving all this into what? Just a
table.
A table with a what's the column structure? You've got the lexicographical ranges again that are just strings.
Yep.
And then you have I guess you don't even need a value at that point because you were zeroing them all out. So it's just a big old table of strings?
I think we got extravagant and we used 2 fields. So 2
columns. Oh, wow.
You know,
somebody was feeling wealthy that day.
Yeah.
2 column table.
Yeah. So I think instead of having to put the code into the string, we actually just have it as a second column.
Yeah, I guess that makes sense. When you're not restricted to key value, you don't have to shove everything into a single string.
Yeah. So 2 columns. So living the life. And of course that's indexed and it works the same way. So we do a lookup, find the one above, find the one below, see if the field in the second column matches. And if it does, then it's in that range and we know what that is.
Okay.
So that's where we're at. Now, this has a whole different deployment model and everything else. And this is really what the article gets into is some of that. And so there's sort of that, and then there's also the performance stuff. I don't know what you want to talk about first or like what makes sense, but
let's switch to the operational side. So the deployment stuff, because I'm curious how, I guess, well, we're about to find out. But the whole like phone home and update thing might be a little bit different given the unique nature of SQLite. So let's switch to deployment and tell us how that changed.
Sure. So I had said before in the abstract, we're doing like a read step and a write step. Mm-hmm. So let's just talk about the read, because what we ended up doing was using SQLite only and read only. Which gives us big speed improvements. Mm-hmm. And what we have happening is that the middleware or the Wafris client in whatever environment it's working on, we developed what we call like an upsync and a downsync systems. And so the downsync takes an API key and pulls down the latest database that you have. And it does this from the client reaching out to Hub instead of Hub trying to push stuff in. Okay. This works much better for deployment because, and from the user experience side now, this has gotten much, much more successful. We have many more people able to actually successfully install this because, they update Composer, they update their gem file, whatever, run this, and it just works. I mean, that's the goal, is it just works. And so what just works in the background is that there's a bunch of, levers for how often this happens. But, every so many requests, every so often, it goes out and it just checks, hey, is there a new database from Hub? Any new updates on the rules? Nope. Okay. Going to check. And it just does that. And when it finds there is an update, it pulls down the database from, essentially S3. And writes a new SQLite database, and then we update a pointer that says like, oh, here's the new database. So there's never any lock contention. We don't do differential updates because these are essentially pretty small. And all of the reads can happen, like in a rollover state. So even as like you're updating this new SQLite database file, you can still have requests rolling through on the old one until it gets the new one, and then it just flips over. So,
okay, this is interesting. Tell me, so you have a client, you have a middleware. Let's say, for the sake of example, it's in Caddy. Okay. And so the millionth request comes in, 100,000th request comes in, and the Caddy module, the Wafris Caddy module, phones home and says, do you have a new hash or a new version number or whatever? Hub says, yeah, I do. Then what happens? Do you have a backgrounding? Where is the script run and by whom? And how do you distribute that script? Is it baked into the middleware?
It's baked into the middleware.
And so in the Caddy middleware client, you have to figure out, so in every middleware client, you have to figure out, how do I download this thing in the background while still serving requests?
Yeah. And, okay. And there's ways to do that async, but even if there's not, it is like 1 out of 1 million requests. Like
Right.
it's going to be, slightly longer. So your P99, percentile 99th, request
Right.
still stays very fast. And we've done a lot of stuff as well to distribute that system. So it's, globally distributed, databases. So it's all very fast. Yeah. And just that piece, this sync architecture of distributing these databases works really well. And this is an exciting thing for me because I had never really, I haven't seen this concept too much in the web development side of things, but on the mobile side, this is how those developers live, which is like, I updated Candy Crush. What that means is you downloaded some new JPEGs and you downloaded a new SQLite database of how much
It
each
has
piece of
a
candy
new
is worth.
JSON string with the level in it. Yeah.
Yeah. Well, and I think it really is the case that from a database nerd perspective, I think it's really neat that you can take, instead of distributing JSON, you can distribute SQLite. Because we also looked at that, like this needs to run everywhere. It is a bunch of rules. It's not that many rules. It's not hundreds of millions. So we could have sent this out in JSON, and then we could have added indexes to it, and then we could have reinvented SQLite.
You just rolled a worse version of SQLite. Exactly.
Yeah. And
SQLite is so universally accessible at this point that's probably one of your biggest advantages of using it is you can just trust that it's everywhere.
Yes. So, and trust that it's everywhere, trust that it has really good performance that's been, tweaked for it, and, trust that they've thought about a lot of things that we don't have to, that we're building on the shoulders of giants, like the best parts of, open source. Yeah.
And so when this new SQLite file comes down, this is full of individual rules that have been set by the user. And so everybody's getting their own SQLite file. And so on the hub side, you provide, I assume, some interface for like saying, block all of these, Lambda IPs or whatever. And then you have a process that generates a new SQLite file and puts it into some sort of identified bucket that the client is then looking for. Is that right?
Yep.
Okay.
It's, of course, like the real world's a little more complicated.
Of course.
We actually distribute multiple SQLite files. A custom rules one, which is like, I want to block this IP, I want to block this user agent, I only want to allow, these IPs, those sort of rules. And then we have another another database that we distribute, which we refer to as like our data subscriptions, which is we have a ton of data about what IP addresses are doing bad things on the internet like right now. Because we have the other, web application firewall service I've run for a long time. So I have a ton of data from that, and there's a ton of other sources. So we take and process all of that data in this huge data jobs, reformat it, and then put it into these SQLite databases that are then distributed. And the same with GeoIP data. We license GeoIP data to do the same thing. So
interesting. So it's not only checking an IP against rules that I have explicitly set, you have some sort of threat list or bad actor list that you're also providing that it checks against.
Yeah. And we had spoken about, like earlier we said, like, well, what do you do if you are in a situation where there's a credential stuffing attack?
Right.
It's pegging the rate limiting, which is good. But the majority of those IP addresses are proxy servers that, is someone's Android app or someone's home PC that's taken over and being used for these attacks. The IP reputation will just automatically stop all of those. And, that's what you want. That's how you really deal with the attack, other than just saying like, yeah, we're going to peg the rate limits until it gets bored and they go somewhere else. So,
And the Geo IP databases is so that if I say, let's block all the people from Oklahoma, because, they're just north of us here in Texas. If I want to block all the Oklahomans, you don't stuff that into my rule set. You send down a Geo IP database that I check against?
Yep.
Okay. And again, that makes sense.
Yeah, and that's really for, the custom rules tend to be a lot smaller. Like, at the far end is 750,000 IP addresses. Right. More likely is a couple hundred or, a couple other rule sets. Like we have individual rule sets to stop like SEO scrapers, like Ahrefs and SEMrush have really aggressive scrapers.
Yep.
Go through your site. Don't want that? You just block them. Same with all the AI scraping that's happening now. Like you can stop that as well. So yeah. So that's the operational side. And then on the once it's synced down, we had run a bunch of these same tests and we found that so this is just like wins stacking on wins from using SQLite. We have a win that it's so much easier to set up because you essentially don't have to set it up. It just works. We have a win that we're able to have it work across regions and all sorts of distributed systems, and it works just out of the box for so many of these different client platforms we need to be in. And then the final win was we found it's actually substantially faster in our benchmarking.
Yeah, this surprised me. I saw all of the operational wins coming, but the fact that it was faster surprised me. So walk me through that.
Sure. So I'm not an expert at all of this, but I'm going to do the best.
You might be the only expert at this point.
Well, this was something I tried to express in the article about this, which is this was not an impartial, unbiased benchmark of these things. We have a weird use case. Like we don't have to do any writes to the SQLite database. We're just reading from it. We're distributing it ourselves. It's only local. Like all of these caveats on caveats. So, and the other piece of it is, it is so hard for us to get people to update Redis that it's not a situation where, oh yeah, if you put it in this other mode or you do this other thing to it or you
compile with this flag, no way.
Yeah. Like we had trouble getting people to set it up to start, just functional setup. And then there's even some real like top level things we couldn't get people to consistently set. So this is a biased benchmark, but SQLite running locally and Redis running locally, sort of out of the box for both. SQLite just blew this away by 3x. And
3x?
Yeah. So so here's how I tested. So I said we have these data sets. So basically I put the GeoIP database into the sorted set, and then I made an identical one that was set up for SQLite. And then I took a random sampling of different numbers of unique IP addresses from a reputation IP and split that half IPv4 and half IPv6.
Okay.
And then I took all of those IP addresses, and so this was in chunks because I was curious like how this would work. So I did that at 1,000 IP addresses and then all the way up to like 500,000 and pushed through. Did that 5 times and took the average.
Seems pretty real world to me.
Yeah. And this is what it came up with. And so there were a lot of Hacker News commentators that were skeptical of this.
As there can be, yeah.
As there can be. Honestly, everyone was really nice and had lots of good things to say. And even the suggestions I thought were interesting. But
I saw one commenter suggested indexes.
Yeah, I thought that was neat. I thought maybe we could look into that. So maybe that's for V3. We'll put an index.
Yeah, we'll see.
All this.
Nobody knows what those are.
Yeah. Yeah. So just try to be nice to everybody. So I think what this is that this functions inside the process. So this is happening inside the process. There's no, like, even if Redis is local, it's still going over a socket. It's still essentially going out to the network, even if that network is your machine, like the local host loop. And it's still, to my knowledge, like we've had to implement some of the Redis protocol. Like it's still like taking this, putting it into the Redis protocol, getting it out, and doing that sort of encoding and decoding across that network socket interface. And I think that's just slower. And
just cannot eliminate it. You just have to do that.
Yeah. And so, and an interesting thing, Stephen Markheim, had pointed me to the SQLite docs where it says like, oh, SQLite doesn't compete with databases. It competes with fopen, like opening a file. And, we're in the fortunate case of like, we're opening this in read-only mode. Like there's no writes. It doesn't care about that. And it just does these as fast as it can. And even if the performance was worse on SQLite, because it's rare that the Redis is actually on the same server as the HTTP stack, it would still be a win because we're not doing, 10, 15 milliseconds to go across the data center.
Jeez, yeah.
And so it's just a win on a win on a win for us. So easier to deploy, people are more successful, less management, faster. It's been great. So we were very excited to write this up, and then hopefully other people that find themselves, they can reach for this tool or this setup and do these things the same way. So
that is amazing. So how long do you think, so you said 10 to 15 milliseconds to get across the data center or, outside to the building and back. How long do you think you're taking in a stack now? When a request comes in, it's handed off to you, and by the time you hand back an OK or whatever, how long do you think that is now?
Oh, it's probably, well, just for the SQLite portion of it, it's probably microseconds. I mean, that's really what it comes down to. Like, and again, the benchmark was just this. Of
course, yeah.
Yeah. We have to do a bunch of these, so it's probably a couple milliseconds. That we would add to each request. But, like the enterprise version of this, that's a DNS-based proxy that's worldwide you have to go through. Normally we advise clients that's like 100 milliseconds that it adds to a request. And that's like, most of the systems that do that, this is a real big tangent, but that's just network effects that you have to go through US East to something else. And you can get around some of that, but it still happens, and it's still flaky, and you still end up in like weird, tough to diagnose situations where like northern Brazil can't get to our site today. I'm like, oh, okay, well, let's look at what's happening, and then you find out it's ISP issues and BGP.
Is this an actual call you've been on?
Oh my, so many of these. So yeah,
gosh,
So this is just a lot more. The term I like is legible. Like it's easier to understand what's happening. And I think that brings down the administrative burden on developers. And again, the mission is to make this a default, to make this something that's just easy. It's a no-brainer. It's just so frustrating. Every site gets attacked. Like every site has these stupid bots that are just attacking sites. And maybe today's your unlucky day that they actually find something. Maybe today's the day there's a 0 day that nobody knew about.
Right.
Maybe today's the day that your number came up at the top of the CSV of the domains they're attacking for, weird SEO purposes. And you get there's just no way of knowing. So since every site gets attacked, to me, it just makes sense. Every site should just have a default, some set of security tools, and we're trying to provide that. So.
And y'all are going hybrid, right? There's like a free open source community edition, and then there's the paid version, because you really do just want people to install this thing.
Yeah. So there's a couple levels of that. One level is there's a freemium, which is basically you can go in and set custom rules and things, and then what you really pay for is the data subscription stuff. So if you want to go in and just use this, not set any rules, just install it and just look at your traffic and see what the top IP addresses are and things, you can do that. And then if you want to start blocking them, you can do that for free. And then there's also the piece of this, which is this is a SQLite database. Like we have this whole syncing architecture stuff, but it's a SQLite database. You can crack it open. I explained the most complicated part of it on this podcast, which is this lexical decimal thing. If you wanted to, you could implement that yourself. But if you want to just block 200 IP addresses, you could also just write those into the SQLite database and distribute the SQLite database yourself. Like check it into Git, deploy it with your application, never talk to us. We don't know anything about it. Like that's also a possibility. From there it goes up to, you have 20 servers, you need more stuff, you need more things, but yeah. So
cool. Tell us just quickly, and then we can wrap it, but tell us about the upsync. How do you get the reports and stuff back?
So again, a flaw, I think, of our version 1 architecture, which was based on Redis, was that we had merged those things together into essentially one stored procedure. that it was both.
Oh.
And that was a performance thing, which is we don't want to make multiple calls to Redis. So we have one Redis call to preserve the network, latency.
Penalty,
And what the stored procedure did was here's all of the request information, the user agent, the IP address, and then the response it got was, hey, that's a pass, that's a fail. Mm-hmm. And so it would then record in that Redis instance what happened to it and all the metadata and do all of the pre-computes of the leaderboards and stuff. So now with this split, we have an upsync, and the upsync is just an async, REST endpoint essentially that can batch send, here's the last 200 requests, like what we did with them, what the disposition is, and that's what shows up in Hub now. So
as the request is coming through the stack, you open all the rules read only, and then I presume you open a second or a tertiary database and do the write, and then at some point somebody comes along and sends the batched requests up.
So we don't. This is very dependent on the client. So in the Rails client, we have a mechanism where we can batch multiple requests together in memory and then send them up.
Oh, I see.
And then we're tweaking that for each different stack. Like OpenResty is the one I'm working on now. They have a whole different shared memory model for how things work and stuff. And so there's a different.
Gotcha.
But
So let's say on the Laravel's tough because it dies after every request. On the Caddy side, you're just keeping 10, 20, 30 requests or like the format that you're going to send to the hub. You're just keeping that in memory, and at some point you tip over and fire them off.
But even in Laravel, this gives us a lot of flexibility that if it makes sense, we could write all these to files on the local machine and then scoop them up on every 1,000th request. Mm-hmm. We could write them to a SQLite database, like per process, have a different SQLite database just for writing. And then that gets eventually pushed up to the API. But, by splitting it with the reads have to happen super fast. So it's very performant. That's all the rules. That's the front end. We can take our time, because what's it matter if it's 250 milliseconds or a full second, to upload all the last set of requests. That's okay. No one's mad about that. So it's another advantage of this by splitting the architecture. Cool. That we're able to do that. So
cool. This is great. I read the article and thought, oh man, I know exactly who wants to hear about this, and it's a bunch of database nerds. So I'm so glad that you wrote that and that it went so well, both on Hacker News and elsewhere. So give us a place we can find you, a place we can find Wafris, and give us your final closing pitch for Wafris.
Sure. I guess wafris.org, wafris.org. You can go there, and at this point, other than the Rails client, which is V2, all the clients are V1, and we're sort of gently encouraging people to wait for the V2. Not that the V1 doesn't work, but it's just not easy, and we want to make this easy. So the Laravel client, we're working on a V2 of that. We're working on all these other ones. So that's where we're at for those. Sign up. The other thing you can do is follow me. I am on LinkedIn. There's not a lot of Michael Buckbees on there, so you should be able to find me. Same for Twitter. I'm pretty active on Twitter as Buckbee. So please. And if anyone has a better way of doing this, reach out. I would love to know it just for my own sake. So yeah.
Here's my promise. If anyone has a better way of doing this and they reach out to Mike and y'all talk about it and figure it out and it is actually better, you can come on the show, whoever you are, person, and you can talk about how it was better and how interesting it must have been, because this is wild already. So that's my pitch to you, dear listener. Well, thanks, Mike, for doing this. This was an absolute delight. I'm sure there are not many podcasts that want you to go into the nitty-gritty details of sorted sets in Redis, but that was super fun for me. So thanks for being here.
At some point, most people's eyes glaze over, and they're sort of like, okay, what's a Redis?
Sure, guy. Sure. Yeah. All right, well, y'all can check this out, I think, just on my YouTube channel at youtube.com/@AaronDFrancis. Let me know what you think, and we'll see you next time.